All right, kiddos, let me give you a quick recap of how we can kind of plot these quadrilaterals using the same distance and slope formulas we have in the past to kind of make some sense of some of these things. So let's talk a little bit about coordinate geometry. So here's a problem we can consider. It's a great problem. And we have this quadrilateral below, and this quadrilateral has the vertices at -3, 3, so that's right here. And why don't I just write -3, 3 on there? Probably more helpful to do that. And then 0, -1 is right here. And then 5, -1 is right here. And then 2, 3 is up here. All right, so those are my 4 vertices that define this quadrilateral. And the first thing I want to do is consider what it is. And it looks like it's a rhombus. Remember, rhombus has 4 congruent sides by definition. So I want to show it is, right? So to show it's a rhombus, I want to show it satisfies the definition of a rhombus, right? So to show it's a rhombus, I really need to show 4 congruent sides, right? That's a definition of a rhombus. I don't care about all the other properties, which also happen to happen. But what I do care is that I want to show that this side is congruent to this side, is congruent to that side, is congruent to that side, right? And so the way I do that is using the distance formula, right? And the distance formula, if you recall, is the square root of the difference in the x's squared plus the difference in the y's squared. Now that's a direct result of the Pythagorean theorem, and some of you have been really good at just using the Pythagorean theorem to solve. It's the same thing. Right, so so the distance between 2 points is given by that formula. What's nice, however, is that this length and this length, I don't really need, although I don't need to use the distance formula. Why? Yeah, because they have the same y value, right? Note that these 2 points have the same y value, right? So the distance between those 2 points is just going to be basically the difference in the x's, right? There's no difference in the y's. So if I ask myself how far is it along a line, a horizontal line, from -3 to 2, since they have the same y value, it's just 5, right? And you can just count, right? So one way is to just count, right? 1, 2, 3, 4, 5. Boop. Right, so that length is 5. And if you want to use the distance formula, great, you get the same thing if you do it correctly. How about to find the distance of the bottom, the base? Well, again, they have the same y value, -1 here, right, and -1 here. So it's the same as finding the distance between 2 points on any horizontal number line, right? So what I'm going to do is ask myself, how far is it between the x's from 0 to 5? Right? Or you can just count. 1, 2, 3, 4, 5, right? Either way, you get 5. Okay? So if you want to use the distance formula, you certainly could, but you don't have to, because those 2 points, 0, -1, and 5, -1, have the same y value. Right? They're along the same horizontal line. As do these 2 points. They have the same y value. Right? So you can just count or think about distance on a line, right? A horizontal number line. So anyway, those are 2 lengths which we have. We're trying to show, again, we have 4 congruent sides. That's our goal. So right now we have 2 congruent sides. Right? It's not enough, but we're on the right track. Okay. Now I'm going to have to use the distance formula to find this length. Right? And to find that length, I'm going to use a distance using these 2 points, 2, 3, and 5, -1. Right? For those of you who like to use a Pythagorean theorem, here's a little triangle you'd use. Right? Your A, your B, and that would be your hypotenuse C. Right, but I'm not going to do that. I'm going to use the D formula, which is the same thing, really. Okay, so in order to use that, I just take the square root of, wow, that's rather annoying, sorry. So to find this length, and hopefully it's going to be 5, I'm going to take the square root of the difference in the x's, so that's 2 minus 5 squared, plus the difference in the y's, that's 3 minus -1 squared. Right? So now I just need to work this out. 2 minus 5, that's -3. 3 minus a -1, that's 4. right? So it's negative 3 squared, which is 9, 4 squared, which is 16. So that's going to be the square root of 25, 9 plus 16, and of course the square root of 25 is 5. Ooh, great. Okay, so now I have 1, 2, 3 sides that are congruent. Right, so I have one more job, and that's to show that this side is also 5. Right? And to find the distance of the length of that side, I just use these points, negative 3, 3, 0, negative 1, and the distance formula. Right? So let's do that. Let's go there. Right? So this remaining side, I'm running out of room, but nonetheless, that remaining side, this one here, its length is going to be the square root of negative 3 minus 0, those are the x values, squared, plus the difference in the y's, 3 minus negative 1 squared. Right? Negative 3 minus 0 is negative 3, which when squared, negative 3 times negative 3 is 9, plus 3 minus negative 1 is 3 plus 1, which is 4, which when squared is 16. Oh, and then 9 plus 16 is 25. Square root of 25 is 5. Oop. So that side is also 5. Okay? So as of now, I've shown that I have a rhombus. All 4 sides have the same length of 5. Therefore, I've shown we have 4 congruent sides, which is what a rhombus is by definition. Right? And we work back to the definition. And I've shown that. Okay? How about if part B, it asks us, or I ask you, to prove the diagonals are perpendicular, right? So here again are my points. I'll relabel them. That's negative 3, 3. Here's 0, negative 1. It's nice to have the name of the coordinate by the point, I think. And then that's 2, 3. Right, so here I want to show the diagonals are perpendicular, right? So how have we in the past shown perpendicular lines? Yeah, that's right. We use slope, right? Recall that slope is the change in y over the change in x. Okay? And if lines are indeed perpendicular, their slopes will be, that's right, opposite reciprocals. Right? So first off, there's one diagonal. And so to find the slope of that diagonal, I'm going to use the points 2, 3, and 0, negative 1, right? Those are the two endpoints of that diagonal. And so when I do that and use the slope, it's 3 minus negative 1, difference in the y's, over, since I started with a 3 on top, I have to start with a 2 on bottom, 2 minus 0, right? Difference in the y's over difference in the x. 3 minus negative 1, of course, is 4 over 2, which is a slope of 2. Okay, so that's a slope of the blue diagonal. Let's throw in the other diagonal, right? And so for this diagonal, I'm going to use the other 2 points, right? Because those are the endpoints of that diagonal, right? So that slope of the black diagonal is going to be 3 minus negative 1, right? The difference in the y's over the difference in x's. And since I started with 3 on top, this 3, I have to start with a negative 3, its partner on the bottom. Right? So it's 3 minus negative 1, difference in y's, over negative 3 minus 5, difference in x's. Right? 3 minus negative 1 is still 4. Negative 3 minus 5 is negative 8. And that simplifies to be negative 1/2. Okay? So I have the slope of negative 1/2, the black diagonal. I have the slope of the blue diagonal as 2. And what do you notice? Aha, yeah, they're opposite reciprocals, right? So since the slopes are opposite reciprocals, I'll just say ops recips. That means the diagonals are perpendicular. Okay? So that's a nice little review of how we can use slope to show, we can show parallel using slope, same slope, or perpendicular using slopes, opposite reciprocal slopes, as we did in this case, and distance formula, right, to show congruent sides. Okay, so in conclusion, if you want to show something's a rhombus, or whatever the case may be, whatever quadrilateral it may be, you try to show it satisfies the definition of that quadrilateral. If you want to show it's a square, you got to show 4 congruent sides and 4 right angles. If you want to show it's a parallelogram, you got to show both pairs of opposite sides parallel, right? So you always work back to the definition and try to show that. Right? Distance formula, here you go. Slope There you go. Right? Things we've done in the past and things we'll continue to do. Have a great weekend. Bye-bye.